Hey guys, what's up and welcome back to Gem City Photons. So this weekend I spent about 14 hours staring at CAD. Let's get into it. So as I've mentioned in previous videos, I have this insane idea that I want to be able to run my show at 100% brightness. That doesn't mean I will all the time. But it means that I want to be able to. Therefore, I have to design all of my power distribution, power injection, and everything to be able to accommodate that. So, like many people, originally I was planning on using Meanwell power supplies, the formidable LRS 612, which many people use successfully. And if we plug that data into my spreadsheet here, you never want to go over about 80% on those power supplies for continuous load. So 480 watts, that's 80% of 600 watts. And then for power efficiency, they claim about 90%. It's probably about 88, but we'll just go ahead and put 90 in here. So you can see that my spreadsheet tells me that we need 4 power supplies and that each power supply, assuming a perfectly distributed load, is going to be pulling about 460 watts. That's really close to kind of the upper limit here. I mean, of course, you can go to 600 watts momentarily and all that kind of stuff, but it's a little too close for comfort. Also, the power distribution modules that I'm using can actually handle 60 amps per module for 8 ports, and each port is fused at 7.5 amps. And I wanted to be able to leverage that. I actually need to be able to leverage that because my injection point currents actually get pretty close to 5. So, I want to have some headroom in there. So I decided on that particular power distribution board. And the math with that distribution board and these power supplies just doesn't work out very nicely. So then I started thinking, well, what if I thought about using HP server power supplies? So you can get these from places like Server Supply. They're $50 a piece. If you factor in the cost of the breakout board that is necessary for these common slot power supplies, they come out to about $68 a pop. But if we plug the data here, you can actually run these at like full power continuously. They're extremely robust. This is a 1200 watt power supply, but in order to put out 1200 watts, it actually needs 240 volt input. I'm probably not going to do that. So we're using the 120 volt number, which is 900 watts per power supply. And these power supplies are about 92% efficient. And when we plug that data in, we can see that I only need 3 power supplies, and assuming perfectly even distribution, the amount of power we're pulling from each supply has quite a bit of headroom, about 611 watts per supply. So that seems like a much better option to me, and also it allows me to fully leverage the distribution boards. So I can put essentially 30 amps into each side of that distribution board for a total of 60 amps. Now, we're not going to actually hit that, but it's just a nicer, everything just works out more nicely once I decided to use server power supplies. So that's all kind of preamble to get to the point of this video. And the point of this video is that the problem is that, at least as far as I could find, nobody is putting together nice little kits for HP server power supplies. Everything is designed around Meanwell for enclosures. Well, I was kind of dreading this, but I spent like 14 hours this weekend designing an enclosure assembly for these HP power supplies, server power supplies. So that's what this is. We can go ahead and take the lid off here, and you can see the design that I've come up with. I wanted this to be very aesthetically pleasing and also to maximize space. So, and also to be modular. So I actually need 2 boxes for my first year. One is going to be the controller box, and it's also going to have 1 power distribution board in it for power injection. And then the other is going to be purely a power injection box. That box is going to have 2 supplies, 4 distribution boards for a total of 32 outputs. So I designed it to be modular. So this is the controller configuration, but I can very easily just kind of select that, get rid of that, select that, and put 2 additional distribution boards in here. So this is what the power injection configuration is going to look like. You can see that, let's go ahead and get rid of the enclosure here. You can see that I've got some 3D printed parts that hold the power supplies in place. These blocks right here represent the distribution boards that attach to the power supplies. Each one of those has 4 outputs, and each one of these distro boards has 2 inputs. So that means that each supply can supply 2 boards. And yeah, I gave myself plenty of extra room should it be that these are a little larger than the specifications say, these boards that attach to the power supply. And it actually even has some holes in here that leverage the clip-in functionality of these server power supplies. So that's kind of just what I wanted to show you guys in this video. You can see I've included a provision for some metering here, 1 meter per power supply, just to keep an eye on the current draw. And yeah, I went through about 4 different layout designs. Really, the most challenging part was in maximizing a small area for this custom acrylic sheet that I'm going to have cut, laser cut. So in this configuration, you can see we have slots cut out over here. That's supply into the distribution board from the power supply. Same thing on this side. And we have this slot here where we can come in there. And then we have this cut out in the middle so that I can nicely route the wires coming out of these distribution boards kind of under the acrylic sheet here. And then these top ones will just go straight to the output. And then in the controller configuration, this slot right here in the middle also serves for a way to route all of the outputs from the ports from the Falcon F16 V5 controller. So power comes in on this side and on this side and to these 2 distribution boards, and then all of the controller outputs can just slot under nicely there. So that's pretty much it. That's just what I wanted to cover in this video. I'd really like to hear you guys' thoughts on this design. One of the big things was that once it's kind of assembled, I wanted to have plenty of space to stick my arm in here and be able to route wires. So that was one of the big challenges, is kind of making sure that this acrylic sheet didn't come too far down and that I'd have enough room to stick my arm in here. And you know, there's going to be a ton of wires down here, so just want to kind of keep it as tidy and nice looking as possible. So I look forward to hearing your thoughts in the comments, and yeah, that's going to be it for this one. Let me know if you have any questions. As always, thanks a lot for watching, and I'll see you on the next one. Bye-bye.